Hi everybody, my name is SaraAnn. I am an iLab assistant, one of the tutors who works here during the week. This is my third year as an iLab, and during that time I've seen many cases of people who come in tired and sad and frustrated because they've spent more than a few hours debugging simple problems. And it's not because the problem is that hard, it's because their code is poorly written. So in this workshop, I'm going to cover a lot of the good habits that are going to be helpful for your entire career and make your experience in 112 and 111 a lot less painful. By show of hands, who here is in 111? Ooh, okay. Who's in 112? Oh, okay. Who's beyond 112? Okay. So, you might not think this workshop is worth your time. Hacker hours are usually about shinier things, and this seems like kind of like a return back to basics. But this is actually a really important workshop. As I've said, as an iLab assistant, people show up all the time because they don't know best practices. So why spend a whole hacker hour here? Because the more time you spend planning, the less you're going to spend debugging. This is directly related to how experienced you are, but at least for the intro courses, I would say an hour of planning will save you somewhere between 3 and 5 hours of very sad debugging and a headache. You might still be thinking this workshop is stupid. Chill, I got an A in 111, I'm going to be fine. No, you're probably not. And it's not because you're not great at computer science. I'm sure you're a great coder, and I'm sure you're very smart. But a lot of the time, people who do really well in 111 will fail 112, not because it's really hard, but because they are, as my predecessor would say, degenerates. And they don't start their assignments until sometimes the day before, sometimes a little bit earlier, and what starts out seeming pretty doable turns into an emergency that ends up in a failing grade, and that's pretty sad. So ideally, you want to start the day that the assignment is released, but do not start later than a week before it's due. If you don't give yourself time on this, you're going to eliminate any chance that you have to ask SESH and TAs for help. And although the iLabs are here to help you out, lack of planning on your part is not an emergency on ours. The cave is always absolutely packed full of panicked individuals on the nights that assignments are due, and we just simply don't have the manpower to help everybody at once. So don't put it off to the last minute. So what we're going to cover. Assignment descriptions are often pretty difficult to read. Sometimes it's because professors aren't great at writing them. Often it's because you just might not have the experience to know what to look for. So we're going to go over planning and reading those descriptions. For our friends in 111, this might be a little bit above the level that you're used to. That's okay. Just do the best that you can and feel free to ask questions. It's all right if you don't understand all of it. We're going to talk about planning, pseudocode, testing as you go, styling structure, and commenting. Okay, so the first step is reading the problem statement. You can't know how to write a program if you don't know what to accomplish, and this is a really common problem in 112. So I'm actually going to take you through how I would read the assignment descriptions, and we'll do it interactively. If you are in possession of one of the printouts, I encourage you to follow along, mark it up, and do an interactive reading. If not, you can just watch me or get with someone who has one. Okay. A second. Oops, gotta pull this up real quick. Okay. Cool. So the first thing that we're going to take a look at, and you're going to think I'm being silly, but this is going to happen to a few of you, at least in this room, and you will get zeros, and you will be sad. If your code does not compile, you will get a 0. 112 is super strict about this, and so is 111. So before you submit your code, check out the directions here, run it one last time, and make sure that it compiles. All right. This assignment it's a real 112 assignment. Does things in cycles. So it's not what's going to be due for 112 in this cycle, but it's really, really similar. So if you pay attention, it might help you out for this week's 112 assignment. All right, background. For background information, this 112 project is about adding and multiplying polynomials. So a polynomial may be represented using a linked list as follows. For every term, there is one entry in the linked list consisting of the term's coefficient and degree. So right off the bat, this is some meaningful information, and I like to draw things out. So for every polynomial, there's one entry in the linked list. So let's write out a basic polynomial. We have x cubed plus x squared plus 1. And from the description, I can tell that my linked list is probably going to look something like this. So everything is a node. For example, the polynomial 4x to the fifth minus 2x cubed plus 2x plus 3 can be represented in the linked list as a list of terms 3, 2, 1, negative 2, 3, 4, 5. Looks like I've made a mistake, so I'm going to go ahead and edit that. Oops. I'm noticing here that it's going from least significant digits to most significant. Whoops. And that's a note to keep in mind as I move forward. Negative 2x cubed, 4x to the fifth. Notes about representation. Terms are stored in ascending order of degrees from front to rear in a non-circular linked list. So my linked list is going to be a pretty standard linear linked list, and it's going to be going up rather than down, which is different than how I'm reading them as a human. So that's something to make a note of. If I had the paper in front of me, I would jot that down. Maybe I'd highlight it. Zero-term coefficients are not stored, so that's an edge case I don't have to worry about. An empty polynomial is represented by a linked list with no nodes in it represented by null. Okay, so if I'm doing math operations on them, then I should probably know that that's an edge case to look out for. This is going to be an empty list. Degrees are positive integers, except if there's a constant, in which case the degree is 0. So the power that I'm going to be raised to, I'll never be dividing and having fractions, except for constants and regular numbers. Okay, so that all seems pretty reasonable. Now let's see, what am I going to be graded on? We're going to talk about how to read the stub code in a minute, so you can ignore that for now. All right, I have 3 methods: evaluate, add, and multiply. Now, typically, the order that you have to do these in is just going to be the one that they're listed, but you do have to actually go through the code and see what you need in order to move on to the next step and start by 0. Efficiency is not a requirement. Okay, so ordinarily in 112 you have your mind set on how efficient your code is going to be, but for all intents and purposes here, it can be whatever. So if I want to have really long and inefficient code, that's not the end of the world. I should probably try to make it clean, but I can just do what's easiest for me. Okay, this is really important. Don't remove any import statements, don't change headers, don't add any class fields. I'm not going to read all of them right now. Excuse me. But all of these notes here, without fail, every single assignment, there's going to be someone who adds in a library or who uses methods that aren't allowed that do all the work for you. So be really cognizant of what you're depending on and that you're actually writing your own code and following the instructions here. There are 3 sample input files for you to text. So I'm going to need to take input from my files. I'm a 112 student, and this is my first project. I don't know how to do that. So reading Java files as input is something that I should be Googling. And once I've given it my best effort, if I can't figure it out, I can ask an iLab or a TA. In each of these files, the line is a term. The terms are listed in descending order of the degrees here. Okay, so that makes sense. That matches to what I've got. And the respective non-zero coefficients. When you store a polynomial in a linked list, you store it in ascending order of degrees. This is something that I might forget, so I'll probably want to highlight that or make a note. Maybe I'll write it in a comment in my code. Let's see. OK, that seems to make sense. They give me a note on a toString method. toString is usually something that's included by every Java object, so that they're highlighting it as being written individually in this project means that it's different than the Java documentation, and I should take a look at that and maybe try out in any sample code they give me. At this point, I read the directions. I have like kind of a vague idea of what I need to do, but I haven't actually looked over any of the objects or done any planning to figure out what my functions are going to look like. So let's see. What's the next step? I know that seems pretty basic, but the instructions get more complicated as you go along. So taking the time to mark them up and read them over is really important. As I said, you should look up documentation for words you don't understand, reference your class notes, and contact the professor if you have questions. And last but not least, I have found that the most effective way to make sure I'm learning is by teaching. So contrary to stereotypes, computer science is a really social industry, and the best way to make sure that you're understanding something is to teach it to someone who's learning it for the first time. If you can explain it to them in a way that makes sense and is clear, you've probably got a good grasp of it. Does anybody have any questions on how to read confusing problem statements? No? OK, simple enough. All right. So now I'm ready to start planning. See. Whoops. All right. Just 1 second. OK. So oftentimes people are going to be jumping into their code with only a half-baked idea of what they're trying to accomplish and why. It makes a little bit of sense because it's natural that code is a very logical thing. So maybe you kind of start thinking in code immediately. Who can tell me why this is a terrible idea and you should never, ever do it? Who's feeling brave? Anyone? No? All right. Yeah, Maya.
Maybe you might miss an edge case if you go right in without knowing everything that has come up.
Right, you might miss an edge case. But edge cases you can add in later on. That's not the end of the world. What I found to be more dangerous is that when people start coding immediately as a way to flesh out their ideas, they fall into this debugging process, and they have messy code, and they get married to it. So what happens really often is that the deadline is approaching, your code doesn't work, and a professor or iLab assistant is telling you to start over. And it's the most heartbreaking thing you can imagine, because at this point, you've invested so much emotional energy into your code and so much time, and you're really, really hesitant to throw the whole thing away and start over. So plan first. So step 1 of planning is exploring the source code. Understand how the classes, instance data, and methods work. All right. So I'm going to go through. I have the stub code downloaded here, and I'm going to go through the classes that they've included. You can't. Can you guys all see that? OK.
No.
No? Should I zoom in a little more? There we go. So there are 3 classes here. There's term.java, polynomial, and node.java. People often ignore the comments that are included in these. Really, really important that you read them through. So let's look. I have a class term with a float coefficient and int degree. OK, so that's my instance data. OK. It looks like the constructor is pretty basic. There's nothing crazy going on there. My equality operator is going to tell me that both of the terms that I'm evaluating exist and that their coefficients and degrees match. And it looks like it's going to output the toString function as just how I would normally read it as a human. Okay, that makes sense. Let's look at our node class. Okay. Int I node. Oh, this is something that I have myself for interview prep. Whoops. All right. I don't have it here, but the node class is just going to contain the term and the next value. And now comes the meat of it, is the polynomial. So let's see. I'm going to have to read in my polynomial from an input stream. So it looks like they've given me some tools of the scanner that I'll have to use. I'm not familiar with the scanner, so I would go look at the Java docs and look that up. And let's see. Oh, look. Here are the actual methods that I need to be implementing. So add is going to be the sum of the two polynomials, doesn't change either of the inputs. If it doesn't change either of the inputs, that tells me that I need to be creating a new object and returning it. So poly1 is the first polynomial, poly2 is the second, and I'm going to return the sum. Often I'll have people come up to me and tell me that they understand what they're supposed to do, they just have no idea how to get started. What you want to do, of course, is look at the directions for what they say that you have to implement, and usually in the main class, so here it's polynomial.java, you'll see methods here that are listed out but are empty, and you have to fill those and make them work with the code that they've given you to test it, and as well as making your own test cases. Okay, so I have 3 methods here. Which one should I do first? Well, I can't multiply if I don't know how to add, because as a human being, I know that multiplication is just a series of additions. So I'll start off with the simplest case. Okay. I always like to start drawing when I begin my coding process. So here they're telling me that I need to add 2 polynomials. So I'm going to practice that just as a human first. Okay. As a human, when I'm matching these up, their degrees don't match. So I'm going to make a note for myself. Make sure term degrees match. Since I don't have any of the 5th, I can just bring that down here. And so on. Here their degrees match. So I'm not going to change the degrees, but I'm going to update the term. I don't have anything for squares, so I can ignore that. I only have one for degree 1. And I add this here. OK, and I know that they're all going to need to be new nodes. Who can think of a couple edge cases for this that I might want to look out for? Right. So edge cases. May have a degree in one and not the other. Great. What else? Yeah.
I'm good with negative x cubed and the other, so they cancel?
The directions told me that I wasn't going to have any negative exponents, so I don't have to worry about that one. What else?
Any negative exponents, or like negative 2x cubed and 2x cubed?
Negative coefficients, yeah.
Yeah.
So I could have negative coefficients. Great. And what else? Any other edge cases? Yeah.
If either of them are like empty.
Okay, yeah, I could have a null list. Okay, great. So I've given some thought to my edge cases. Now, as a human, I'm ready to kind of start. Yeah, oh yeah, Steven?
What's an edge case?
What's an edge case? Who can tell me what an edge case is? Yeah.
When the code doesn't as intended to, or like something you didn't foresee.
Yeah. So normally, I might expect all my coefficients and polynomials to match perfectly. An edge case is an input that's a little bit out of the normal. Maybe it's an error case. Maybe it's something that will work that just follows a different execution path. So when you think about your edge cases, you don't have to code for them right away, but you do have to just keep them in mind in case it's something that you're going to talk about later. All right, I'm ready to start planning out my actual code. Oops. Okay. So I need to produce a new linked list out of my inputs here. That seems reasonable enough, but I'm not sure how I would need to match up the terms. I see that I have x cubed here and an x fifth here, but I'm not really sure how to make sure that they correspond with what the coefficients are going to match with. For people who are in 112 now or have done it, how might I get started with that? Anyone? Okay. I could, oops. Yeah.
I would start by traversing over the highest degree.
Okay. So if my highest degree is going to be up top, then I can make a reference to each list. And then what do I do? Well, I compare the degrees. All right. So, all right, I'm seeing that the degree for A is greater than the degree of B. This is as big as it's going to get. So I can immediately bring A down. So step one, and I'll write my pseudocode as I go. So traverse both lists if one degree is greater than another. Bring term down. Okay, so I can create a node here. Now what? Well, the degrees are going to go down. There's nothing here that's going to match x to the fifth, but there might be something that matches x to the third. So I'm only going to move one. And now I'm going to examine the second term. So again, this looks like it's going to be an if statement, so this will go along with that if condition. I'll move forward in larger list. Okay, now I have two terms that are the same. All right, it seems like this is going to be some kind of a loop, so I'm just going to make a note for myself. I don't know how big my linked lists are, so probably some kind of a while loop. All right. So when I've moved forward, I can assume that that's going to be the next iteration of that loop. All right, now I have degrees that match. So that's another case here. If degrees match, I'm probably going to want to add the coefficients. And since they're only going to be getting smaller, I can move both nodes forward. Okay, that makes sense. and so on. My final case is that I have a constant versus an exponent, or a variable. But that's just another version of having non-matching degrees. So I don't really have to worry about that too much. Edge cases. Well, I know that if I have a null input, it's basically like adding 0. So I'll make a note for myself up top here that if one entry is null, return the other. All right, this is enough to get me started. So I'm not going to go through everything. But at this point, I have an idea. And I would use a couple more cases, maybe put in some edge cases, and make sure that I'm covering everything that I need to. My pseudocode is pretty clean, so I would start coding. Now, that brings us to coding best practices. What I see a lot, does anybody have any questions about whiteboarding and how to visualize things like this, and where to get started if you just have no idea how to start thinking about your algorithm? No questions? Yeah.
I didn't understand what you did with if one entry is null, return the other.
Oh, OK. Well, let's think about that as a human. OK, so that's the thing that I always encourage when people come up to me for tutoring is if thinking of it from a code perspective just isn't working for you, think of how you would solve this in a normal everyday situation, and then translate that to a computer and make sure your code will understand it. So what does that scenario mean to me as a human being? Well, if one entry is null, so that means that I'm adding a polynomial to nothing, to a null pointer. Well, that's like adding it to 0. So as a human, if I'm asked to add a polynomial to 0, the answer is the same as it was before. So if I have a null input, I just return the other thing. Does that make sense? Okay. Yeah. Any other questions? Cool. All right, coding best practices. Modularity. Who can tell me what modularity means? Yeah.
Oh, it means like making your program into like composable components.
Yeah. So if you're in intro courses right now, you're going to start learning about methods in a few weeks. Methods are subroutines. So that means that you have a bigger goal that you want to accomplish in the end, but there's little components that you're going to need during that to help your process along. For example, if I have a program that is going to need to tell me how much my college tuition costs, I might need to take into account how many classes I'm taking and the cost of those classes, and maybe my on-campus fees and any books that I'm buying. But all of those could potentially be computed separately. It might be easier for me to modularize those and compute them in their own separate code blocks and then just add the results. So that instead of adding a whole lot of formulas, I just have discrete pieces of data that I can add 3 units instead of many. So modularity. This method is accomplishing adding all of these terms together. I don't really see how I can change the core of it, but maybe I can check for edge cases separately. That'll make my code a little bit shorter in the actual method. So when I'm writing the code for this, I would probably make a separate helper method to check for me that I'm not dealing with any edge cases. That way, I can make sure that that works before I check my entire code block. Comments. The algorithm I just took you through now made a lot of sense to me personally, but you're probably not going to have the luxury of finishing an entire project in one shot. In fact, I promise that you won't. Be kind to your future selves. You're going to be looking back at your code when you've lost your stream of thought, when you're tired, when you're distracted. And if you're asking for help from a tutor, they have no idea what your code is like. So make sure that you document your code as you go, have descriptive variable names, and leave lots of comments about what your variables are supposed to be doing and referencing, what your algorithm is going to be like. And if you have an idea that you think might work, but you're not super sure of it, just make a personal note to yourself. And last but not least, styling. Because you're working in Java, white space isn't going to change whether or not your code compiles. However, it is going to change how easy it is to read. Now, I can show you a piece of my own code that I've been writing to prep for some interviews. And you'll see that I have a very specific structure where all of my if statements are perfectly indented. I have, for more complicated things, you'll see these nice pretty lines that'll tell me exactly where my loops are ending, and everything lines up. And that's really, really helpful because a lot of the time, people will come to me with broken code, and they say, I have no idea why this doesn't work. And it's because they're missing a bracket. Because instead of doing everything all nice and pretty, they might have code that looks a little bit more like this. Now, when I'm reading that as a human, I have no idea where one block ends and another begins. And that's a great way to make sure that you're returning data at the wrong point, or that you're not looping as many times as you think you are, things like that. For myself, people think I'm a little bit crazy. I like to have everything immediately below. So in my for loops, typically they'll look like this, where the brackets for starting and ending the loop are vertical. It's more common to do it with a hanging indent like that, but I like to be able to draw that very clear line. I really highly recommend this for beginners, especially if you're first starting out with if statements and loops, because when you nest a lot of conditions, it can be really easy to kind of lose where you're going and get confused with that. So there's a couple styling tips. Okay. Does anybody have questions about how to develop a style that you're comfortable with, or about self-documenting code, or how to write good comments? No? Okay. All right. Incremental testing. Raise your hand if you have ever written a whole program, doesn't have to be a huge one, and then tested it. Did it work? Keep your hands raised if it worked. Oh, there's not a lot of hands up in this room. Now, that's something that might work in 111 because you're going to have really small code blocks and they're not going to be very complex. But let me tell you the number of people that come to me or that are relaxing, playing a video game here on Thursday night and say, yeah, I finished my data structures project days ago. I just have to test it. Yikes. This goes along with the idea of modularity and why you want to break things up into smaller bits and pieces. Don't ever start a new goal until you're sure that everything that it uses works perfectly. Because if you're coding for 3 hours and then you test and it breaks, well, something went wrong in the span of the 3 hours that you're coding. But if you test something, build another thing that uses it, and build another thing that uses it, when it breaks, you can be darn sure that whatever is going wrong happened within the last 20 minutes. It's a lot simpler to debug. So write your code in small units and test as you go. Last but not least, don't be optimistic, plan for chaos and stupid users. This goes along with the idea of edge cases. So probably, you know, Sesh isn't going to give me crazy cases with decimals in my coefficients or null inputs, but I don't know for sure. And this is something that, especially as you get to higher level classes, you really have to think about, particularly for Professor Francisco, who likes you to plan for worst case scenarios. So don't put yourself in a programmer's perspective. Think of it as a non-technical customer of the product you're building. If you don't know how to use the code that you're writing, what would be most instinctive for you? And what kind of mistakes might you make? Plan for that. Last but not least, version control. Raise your hand if you've heard of Git. OK, wow, a fair number of people. OK, Git is a version control that's really popular in the development community. People push their code to remote repositories on github.com. You can see open source work, code that other people have been working on. Please do this ethically if you choose to do so at all. Do not cheat on your assignments. And we're going to have a whole workshop on Git pretty soon. For more basic use, if you don't know Git yet and aren't ready to learn it, make sure that you submit your project as you go along. This has happened to me many, many times where I'll have a piece of a method that I'm writing that's working pretty well, And then as I continue to write more of it, I go back and change one thing and change a little bit more and change a little bit more. Suddenly, it's 6 hours later, nothing works at all, everything's on fire, and I'm sad, and I have nothing to go on. If you submit your code as you work, you're at least gonna have a recent version that kind of works, or even have a couple methods that you can count on working. And this is also really helpful when the due date comes up and everyone is submitting their work last minute on Sakai. Sakai has a tendency to crash. So if you're submitting your code for the first time and you have a perfect project that you've spent days on and tested exhaustively and everything works, and you submit it at 11:56, they are going to be absolutely merciless. So make sure that you have something in there, even if it doesn't work all the way, just in case the worst happens, you'll have something that you can be graded on. It also helps if you tell the professor that, oh, this happened to me, but look, I have a history that I started the code early on and I've been working incrementally, because it'll show that you're being responsible, and if you need a favor, they're probably gonna be a little bit more likely to help you out there. Last but not least, for God's sake, be careful of what you submit. Read the specs. So for Sesh's classes for 112, he requires that you submit the .java file, not the .class file. He gives you the .class file. You have all your classes and objects written out. He wants to see what you've actually produced. I have helped many people writing their projects at the very last second, and we've miraculously gotten it working, and they've learned something new, and they submit the wrong thing and get a 0, and it's heartbreaking. This also happens in CompArc and systems, where people forget to put in a makefile, or they don't put a proper tarball or zip file, and the format isn't something that is expected. Professors have several hundred garbage code assignments to read that are all written pretty grossly, and they're not going to take the time to go through your submission and give it special attention. You're probably going to get a 0 on it unless you have a really lenient professor. So it's really important to make sure that your code is submitted in the format that they say. And that brings us to the end of my hacker hour. Does anybody have any questions about anything that we've covered? I know it's not the most exciting hacker hour that we've ever had. They're going to get more interesting in terms of technical aspects after this, but these basic ideas of planning first and coding last are something that is going to save you a lot of time and pain later on in your degree. Coding should be the very, very last thing that you do, and if you've done your planning right, it's going to be really easy, and the biggest thing you're going to need to worry about is syntax and edge cases. When you are not sure, or even if you think you are, always draw out as much as you can and teach someone else and talk about it in groups. As far as cheating is something that happens a lot in the intro classes. It happens with the upper levels as well. No one's under the impression that you're going to be doing these assignments completely alone, and professors don't actually want that. It's really important to be able to talk through your ideas and collaborate, but if you need to write notes to yourself, that's fine. Don't write code with people, and do your very best to avoid looking at other people's code. In fact, I can tell you that iLab assistants are not allowed to look at your code. So don't come up to us and say, my program doesn't work. I don't even want to read my poorly written code, let alone yours. And yeah, I think that wraps it up. Does anybody have any questions? All right. I'll be around if you don't want to ask questions in front of a whole group, or if you want to talk about how to get help from professors or get started jumping into assignments. I know they can be a little bit overwhelming at first. The last thing that I want to emphasize is that smart isn't something you are. Not that you're stupid, but smart isn't something that you are, it's something that you become. And being really, really bad at something is the first step to becoming kind of good at it. So if you're starting out on your assignments right now and you're feeling really overwhelmed, you're not sure how to get started, and everything is complicated and intimidating, it happens to everyone. Just take your time, start early, and really read and plan before you go. You'll be all right. Thanks, everybody.